wabarakatuh, and salam sejahtera. Okay, so I'm going to discuss a little bit about the previous PSPM question. I will start with question number 10 because I want to point out a little bit, especially for question A. Okay, so this question, they ask you to calculate the binding energy per nucleon of a sodium nucleus in MeV per nucleon. The atomic mass of sodium is 22.989769 U. Okay, the key thing here is that in this question they actually give you the atomic mass. Okay, if you guys notice, in your learning outcomes they give you a formula of this one. Okay, but this formula you have to use the mass of nucleus. So it used to be there are two formula, but now you only have one formula, which is mass of nucleus. Okay, so what you're gonna need to do, so I didn't explain this one in class because I thought it's already out of the syllabus, but they did ask this one previously, so I have to explain as well. So what you're gonna do is that you have to find the mass of nucleus first, and then you just have to substitute inside here. So remember that this one is the atomic mass. So if you are looking at the Bohr's model of atomic model, this one is basically the atoms. So the atomic mass actually consists of proton, neutron, and electron. Okay, but if you want to substitute inside this equation, you only have to substitute the mass of nucleus. So basically you have to you have to minus the electron mass. Then only you can find the mass of nucleus before you substitute inside the equation. Okay, so first you have to identify number of proton, neutron, and electron. So they give you 23 and 11. So immediately you know that numbers of proton is actually equals to 11. Number of proton represented by Z equals to 11, and then the numbers of neutron is basically n minus, so the numbers of neutron is 23 minus 11, so I got here is 12. Numbers of electron, in this case it is actually the same numbers with proton, so maybe I can write this one as Z as well. Okay, so to find the mass of nucleus here, you can use this formula. So obviously you have to do it on this side, but for the sake of showing it to you guys, I just show it over here. So mass of nucleus is actually equals to mass of atom minus numbers of electron multiply with mass of electron. Okay, so I'm going to do this on the next page. So mass of nucleus turns out to be 22.989 769. This one is the mass of the atom minus numbers of electrons multiply with the mass of electron I might have to double check the mass of electron, but that one is in kilogram. So because we are using the U, I think we have to use the same unit. So if you're looking through your formula sheet, and the constant mass of electron in U is 5.49 times 10 negative 4. So it is actually a very small number. Erase this one. Oops. So it will be 5.49 times 10 negative 4. Okay, now you just have to press your calculator. Okay, 22. So just write down all the numbers that you get in your calculator, because the difference is very small. If you round it off, pretty much get the same number. Okay, the unit is in U. Okay, now that you have the mass of nucleus, you simply have to calculate using the normal calculations. So the idea is that first you calculate the mass of nucleus there, and then once you got that, you calculate the mass defect. But remember, the question actually want you to find the binding energy per nucleon, which is basically just EB over A, and EB is equals to delta MC squared over A. So that one, this would be your third step. So you're gonna do the second step, which is calculating the mass defect. So we numbers of individual proton and masses of individual proton and neutron, which is 11. Again, you use the same unit, which is so all of these values you can get in front of your constant list, plus numbers of neutron just now is 12, and mass of neutron is again, just put all the numbers inside here. And minus the mass of the nucleus that we calculated just now. So basically I'm using this formula and then applying inside here, substitute all the numbers, and just check my constant values whether it's correct or not. It seems correct. Okay, now just have to do the final step, which is calculating. So I got here 0.2. Again, don't round it off, just write all the numbers, and there you go. And the last step, which is the third step, is to calculate the binding energy per nucleon. So in this question, they actually state the unit that they want, which is omega electron volts per nucleon. So you can use U, okay, and use C square equals to 931.5, and then you can get the answer in mega electron volt. So it will be EB over A, which is delta MC. So I just rewrite the equation. So 0.200297. If delta M is in U, you can use the values of C square equals to 931.5. Remember, you don't have to square that one. And divided by numbers of, which is 23. Okay, that one is your A. Then you should get 8.11. This one you can round it off. So I round it off to 2 decimal place. 8.11 mega electron volt per nucleon. Or you can write nucleon minus 1.